We just built the largest dry pour concrete slab that I've seen, and along the way, I figured out how to solve a couple problems others are having with their projects, which I'll be sharing with you later in this video. The first thing we needed to do was to get the ground prepped and clear out all of the vegetation. We dug out and leveled this part of our yard for our pool several years ago, so we didn't have to do any digging this time around, but we had a lot of vegetation that needed to be cleared. When we dug out the yard, we brought in sand to use as the base under the pool. And since it was already here, I decided to use that as the sub-base for our concrete slab. Initially, I wanted to make the concrete slab 16 feet on all sides, but since the 2x4s are 16 feet long and you lose 1.5 inches at each corner where the wood overlaps, it was just easier to cut them down and make it a few inches smaller. So instead, we used 2x4s to build a 15'9" by 15'9" inch frame, which is still going to be big enough to fit our 15-foot pool. While screwing the 2x4s together, I used a square to keep the frame squared and scrap wood to brace the corners so the frame wouldn't shift and lose its shape. To keep the frame in place, we added stakes on both sides of the corner as well as a stake to the middle of each side. Then we leveled the frame and screwed through the stakes into the frame to keep it leveled. I had spread the sand out evenly when I cleared the weeds, but I didn't level it because I knew it would be easier to level the frame first. Sand shifts around easily, so it would have been a hassle to try to level the sand before building the frame. But by leveling the frame first, we could line up the bottom of the level with the bottom of the frame and use it as a guide to level out the sand. I used Home Depot's concrete calculator to figure out exactly how many bags we were going to need, and with an extra 10% included to cover any unknowns so that we didn't run out mid-project, that ended up being 177 60-pound bags, which is over 10,000 pounds of concrete mix. I've linked the calculator in the description box for you all, as well as a list of the rest of the tools and materials that we used for this project.
I'm gonna put them about like that. That way you can cut them open.
Okay.
I think with y'all good alarms and all that stuff, it's gonna take y'all a minute, you know.
As my partner started moving bags to the backyard, my kids and I got ready to start working with the concrete mix. The first goal of the day was to get the frame filled halfway with concrete mix before adding any reinforcements. We went with the 60-pound bags because they'd be easier to handle than the 80-pound bags, but they're still heavy. We found that the easiest way to dump them out was to slice through the middle with a shovel. Then you just flip the bag over, and when you lift the bag up from the sides, all the concrete mix dumps out. This kept us from having to lift the full weight of the bag to pour the mix out. We raked the concrete mix out evenly as we went and added more bags until we had the frame about halfway full. To reinforce a slab of this size, we went with rebar instead of wire mesh because it's rigid, it'll add more structural support, and it'll better absorb stress on the concrete from things like weather changes, which will help prevent cracking. You don't want rebar to touch the edges of the concrete because it'll rust if it's exposed to the elements. So we cut 3/8 inch rebar down to 15-foot long pieces, which leaves a few inches between the ends of the rebar and the frame. We laid the rebar out in a grid outside of the frame, spacing them about 2 feet apart. Then we used wire twister to twist rebar wire around at every cross section. Once we had it all tied together, we moved the rebar over and centered it in the frame. Then with the rebar in place, we got back to work filling in the concrete.
Je ne veux pas poser mes pieds, je ne veux pas partir, je veux continuer l'aventure, je veux y rester.
When we got to this point, we started overfilling the frame on one end, then we used a 2x4 to screed the concrete, which knocks down the high points and makes it easier to tell where your low points are. Then, as we worked our way from one side of the frame to the other, we opened more bags and raked the concrete out to fill in those low points. This was easier than trying to fill the frame in all the way before screeding, and it kept us from wasting concrete by adding more without knowing if we needed it or not. There are 161 bags of concrete inside the frame, including these bags that we haven't busted open yet. And then we have 16 extra bags left on the pallet over there. We're gonna start by emptying the rest of these out. Then we're gonna screed back and forth, and then we'll decide if we need any of what's left on the pallet over there. One of the nice things about the dry pour method is that you're not rushing against the clock to get done before your concrete hardens. So we were able to take a lunch break, get cleaned up, and rest for a bit before getting back to work. And that break was needed because screeding a dry pour slab of this size was a lot of work, and it took us the rest of the day. First, the 16-foot 2x4 wasn't long enough to screed with since it needed to extend out over both sides to be able to push it back and forth in a sawing motion. So I had to use a piece of scrap 2x4 to attach the two longer pieces of 2x4 together. Second, because it was such a large pad, the concrete was heavy and it took a lot of effort to screed with that much weight resisting the 2x4 as you're trying to push it along. We could have done the slab in two parts by adding a 2x4 in the middle of the frame. Then we could have gotten one half of the dry pour done before doing the other half. That would have been easier to screed, but it would have taken twice as long to get the slab done, and we would have needed to leave rebar sticking out of the first half of the slab to be able to tie it in with the second half. So doing it all in one go just made more sense for us. We worked our way from one side of the frame to the other, and after each pass, we added and raked out more concrete to fill in the low points, which are really easy to see after you've made a pass with the screed. Eventually, we worked our way across the frame from every direction, and by the time we filled in all of the low points, we had gone through 170 bags of concrete. Once we got to the point where we didn't need to add any more concrete, we started focusing on getting a smoother finish on the surface. When you're screeding, the continuous sawing motion, along with slowly pushing the 2x4 forward, causes the aggregate to settle right below the surface, leaving the smooth powdery cement finish on top. The vibration from that sawing motion also helps to fill in any air pockets as the aggregate settles. I've seen a few videos where they attached a palm sander to the top of their screed, which is a great idea if you're working by yourself or if you have a smaller area to screed. You also want the concrete to be slightly overfilled while screeding, so that there's always a little extra concrete along the leading edge of the screed that can fill in any gaps as it settles. We had a few areas where there wasn't enough extra concrete mix, and you can tell because there was still a lot of visible aggregate after screeding. When we had spots like that, I'd rake some of the extra concrete over those areas before screeding again, and that usually solved the problem. All right, it is 8 p.m. and the sun is going down, so we are out of time for today. We're really close. I just need to screed it a couple more times. There's some aggregate still showing on the top, so I'm gonna get the top smoothed out a little bit more before I start going over it with the paint roller. So we are calling it a day, and I will see you guys tomorrow. It's 8 a.m. the next morning. I'm out here getting ready to get back to work on this concrete slab. Everything held up fine overnight. Thankfully, we didn't have any moisture. There was really no dew overnight. So the slab has stayed bone dry. So we're gonna start screeding this thing, get it to a point that I'm happy with, and then I can move on to the next step. We've screeded the concrete a couple more times and the finish is looking really good. You can still see the lines from the 2x4 running over the surface, which is what the paint roller is for. There's some spots where you still see a fair amount of aggregate on the top. I tested out the paint roller on those spots and it made a difference within a couple minutes. So I think spending some time just focusing on paint rolling will probably fix the rest of the little issues that the screeding just didn't seem to take care of entirely. Plus I've got some of the sifted powder that I can throw on top if I need to, if there's any areas that just don't have enough. So I'm gonna spend a good chunk of time with the paint roller and see how it goes. To roll the surface, I used a 3/8 inch nap roller and a telescoping pole, and I gently rolled back and forth over the surface without applying any pressure, starting in the opposite direction of the screed lines. At this point, I was just so tired of screeding that I figured I could test out the roller in one little square section to see how well it would work to smooth out the screed lines and to see if it would make a difference where there was still some noticeable aggregate showing. And if I wasn't happy with the way that first section looked, I could always go back and screed it a few more times before trying the roller again. Thankfully, I didn't have to do that though, because this made a big difference in the way the surface looked. I have seen a few videos where they used Portland cement for the top layer of their dry pour, and while it looks nice, I think the top layer would probably chip and flake off after a while. So I didn't want to leave that thick of a layer of cement on the surface. So instead, I sifted some of the concrete mix to separate the aggregate from the cement powder, and I used the cement powder sparingly in a few areas that needed it, which honestly wasn't much since the roller did a pretty good job of pulling up and distributing the powder. I've been testing out working with this edger, trying to get a little bit of a rounded edge so that we don't have a sharp corner. The only issue is that whenever I put the tool in, it leaves a smooth surface where there's more powder, and then it's kind of rough where the aggregate is. What I've been doing is kind of taking this tool and pressing it along the edge, because I find that if I try to run it back and forth, that it snags on the aggregate and it will take a little chunk out, which is not what I want to do. So I'm going to take this tool and go all the way around, and in the areas where there's just a ton of exposed aggregate, I might fill in just a tiny bit of powder to go over it to try to get a smoother surface. I tried that over here. It seemed to work pretty well. I don't want to add a ton because I don't want big chunks that are nothing but powder, because I feel like that'll be the area that crumbles off whenever this is done. So I'll add just like a pinch of powder to try to get a little more of a smooth rounded edge, and then press it in with my tool. And then when I'm done with that, I'm gonna go back over this entire slab 1 or 2 times with the paint roller, and then I think I'll be done. Okay, I'm done going over everything with the paint roller. My edges are as rounded as they're gonna get, and I think that the surface is also as smooth as it is going to get. So I'm gonna get the hose out and get my first mist done. Okay, I'm gonna probably spray the mist up in the air to begin with, and then kind of glide it over the pad. That way I can kind of control how much I'm putting on. I figure starting with less is better, and we'll just go from here. I first discovered this method when Cajun Country Living shared their first dry pour, which they've done several of now. I learned a lot from their videos, and I implemented several of their suggestions while doing my dry pour. I'll share with you in a minute why I think we need to change the watering schedule though, but initially I had planned on following their suggestion of doing 2 mists with an hour in between, then 1 shower per ½ inch of thickness, also an hour in between. I started with the nozzle pointed upward, but it was just such a fine mist that the wind was blowing it away. So I ended up directing the mist right at the concrete, holding the nozzle at about waist level, and that worked fine without causing any pop marks or disturbing that top layer. I couldn't get the mist to reach the center of the slab though, so I did end up having to turn it onto the shower setting with the lowest possible pressure, and that worked without messing up the surface just to reach the center of the slab. I sprayed enough water to wet the top of the concrete, but not enough for the water to pool. All right, I'm gonna leave this here and I will be back in an hour. This is when I started to really think about the watering schedule and why it might not be the best way to do it. I went to check on the concrete after 30 minutes, realized how fast it was drying, and decided not to wait any longer before doing a second mist. Leading up to this point, my partner and I had been talking about how this project was going to go and comparing the dry pour method to his experience with concrete after 30 years in the construction industry. With a typical wet pour, if you have concrete that starts to dry before you can get the rest poured, it can create cold joints, which are unbonded layers of concrete. I've seen a few people talk about issues with the top layer of their dry pour delaminating, so I started thinking, what if the top layer of the concrete is drying out, which stops the bonding process? Then when you shower the concrete, the crust isn't properly bonding to the rest of the concrete underneath it. I've since looked into this more, and I found one other channel called Michael Builds, who brought up the same issue, and he came to the same conclusion, that the top layer, or the crust, is drying out before the first shower and isn't bonding to the rest of the concrete underneath it. I'll link his video in the description for anyone that's interested. So at this point, I decided to do 3 mists with only 30 minutes in between, but I think even that was too long. As you can see, between the small amount of water, the fast absorption, and the heat, there's just no way to keep the concrete from drying out and stopping the bonding process, even if you wait just 30 minutes in between, because it's already drying by the time you finish each mist. If I were to do this all over again, which I will be in the future on another project to test this theory out, I would mist the concrete continuously, making sure not to mist it so much that it causes any standing water, but enough that the surface never dries out once the misting process has been started. The concrete doesn't need to dry for the crust to form, because that bonding process starts as soon as you get it wet. So as you mist the surface just enough to keep it from drying, the crust will form. For the shower schedule, the standard advice has been to do 1 shower per ½ inch of thickness. That technically would have been 7 showers since my pad is 3½ inches thick, but I went ahead and did 8 just to make sure I got the concrete fully hydrated. With my hose on the shower setting, I soaked each area until the water started to pool before moving on, working my way around the entire pad. As far as the time in between each shower goes, I would follow the same advice I gave earlier about keeping the concrete from drying out, so the time in between each shower might need to be adjusted. For mine, it ended up being closer to 45 minutes in between each shower, with closer to an hour in between as it got cooler outside after sunset, since the concrete wasn't drying as fast as it had been earlier in the day. This is where I think we need to make one more change to the dry pour method, because even though the process of doing a dry pour is different from a wet pour, concrete is still concrete no matter how it's done, and it still needs to go through the same curing process. Curing concrete is the process of maintaining the right temperature and the right moisture level over the right amount of time for your concrete to be able to go go through hydration, which is the chemical reaction that allows the concrete to harden. If you leave the concrete to dry after the last shower, it's not going to cure properly, leading to a weaker bond and weaker concrete that's more likely to crack and crumble. To fix this issue, I think we need to be keeping the concrete hydrated for at least 7 days, if not longer. You can either keep an eye on your concrete and wet it throughout the day to make sure it stays hydrated, or you can cover it with a tarp to keep the water from evaporating as quickly so you don't have to water it as often. We just barely got our dry pour done before it started to rain the following day, but I made the best of it and used the rain to help keep the concrete hydrated. I wanted to try to keep the concrete from getting oversaturated for the first 48 hours, so I covered it with a tarp but pulled it back a few times a day to let the rain water the concrete for me. In total, I kept mine hydrated for 10 days, and you can go longer than that if you'd like, but 7 days really should be the minimum. By day 14, the concrete was mostly dry and we were ready to take off the frame. Going into this project, I wasn't sure how the concrete would look, but it turned out better than I had honestly expected, especially considering how big this slab is and the fact that this was my first time doing a dry pour or working with concrete at all. We're planning on doing another dry pour this year so we can test out the idea of keeping the concrete misted until the crust forms to see how well that works, which I'll share with you all when we get there. I'll also be putting this dry pour to the test in a few months when I set up our pool that holds over 4,000 gallons of water, and I'll share an update video with you all to let you know how it holds up. I hope this video was helpful, and if you have any questions, please feel free to leave them in the comments down below, and I'll do my best to answer everybody. Thank you so much for watching, and until next time, you can check out one of these videos linked right here.